Okay, welcome back. We're on page 250 talking about the pyramid or tree structure and how whenever you have a recursive relationship, the thorn in the side of a recursive relationship is I have to fill the table in the correct order. All right, we're ready to move on. Modeling processes on page 251. So typically you want to gather user input. That kind of makes sense. So maybe you have some user requirements. If you do, they're probably going to be poor. But maybe you got some paper forms, like this guy had a paper form like this, right? Maybe this is done on paper. That would be perfect. If somebody gave me that, I would know exactly what data I needed. I need something called a sales order, and something called this, and something called that. Be easy to do. A printed report. If somebody gave me a printed report, I go, oh, I didn't know we needed that. Okay, let's add that in, right? So those... Any form or printed report that they have, it's a perfect place for gathering requirements. And then, of course, you're going to have to do user interface. You're going to have to sit down and interview them and say, okay, this is what I got. Is this right? And they're going to say, well, no, I didn't mean that. And, sometimes they'll just say things. I keep mentioning the thing about the warehouse. They'll say, well, snowshoes are only available in the Water Street warehouse. And you go, only? You mean they can never, ever, ever appear in any other warehouse? They go, well, no, that's not what I meant. I meant they're almost always. And you go, gathering user requirements is frustrating because they're not speaking the same language. When they say always, you need to say always, always, or always maybe. Okay. It's an iterative process. You're going to show them that ERD and say, is this what you want? For example, one of the questions was, does a customer absolutely have to have an order? You might have to ask that question like 5 times before you get a definitive answer. Because one guy might say, well, I don't know, I think so. You go, okay. And then after you've done this, it's an iterative process. You're going to have to go tweak and then come back and say, is this what you meant? And over, iterative. Show them the new updated diagram over and over again until finally you got the answers that you actually need. Okay, so their example is this. So here's a copy of a printed report or something on a web page or something. So I have a College of Business, okay? So this is very conveniently like the top part separated, although, come on. And then a phone number for the college dean and the campus, the address. And underneath that are the department chairs, okay? So this is a one-to-many. It's just like this guy, right? Order and order details. This is the exact same thing, right? But I got a printed copy, so I go, okay. I need to know. First of all, do I have multiple colleges? A college could be one thing, but if you have a university, you could have multiple colleges, like a College of Business and College of engineering or whatever, College of Arts and Sciences, right? So I need to know that. And so I would use this as an example, right? This is pretty good. Now, this would probably not show the foreign keys. I can't see the foreign keys in here. But each one of these guys, each one of these department guys, there's going to be a foreign key going back to the college to tie them together, right? Just like this guy had a foreign key called order number that went back. So this would be like college. And then down here would be like college ID or something, okay? All right, good. I'm going to skip a bit. All right, so we're kind of ready to wrap up. So let's talk about what happens. So an optional parent with optional child, okay? Parent-child relationship. So probably like a one-to-many. An optional parent, optional child, okay? Makes sense? A mandatory parent and an optional child. That would be like an MO relationship. An optional parent, mandatory child, and a 0M. Okay. And by the way, I'm not using crow's foot notation here, right? I'm just saying it out loud. So, we're talking about, optional, right? And then a mandatory optional. Dang it. And then an optional mandatory. And then a mandatory. So, right? Those are the 4 combinations of optional and mandatory, right? Okay. So in crow's foot world, I'm not going to be able to do it here in Notepad, but in crow's footnote world, you know how to do that, right? Okay, good. Can the database easily create a rule to enforce cardinality? How easy would that be to do? So if I have a one-to-many, I can say, yeah, I mean, I can create a mandatory rule that you actually have to have at least one. But what about the rule that says you can only have 4 players and you must have exactly 4? Well, I'm sorry, the crow's foot notation really falls apart there. You'd have to scribble that off to the side, so to speak, that says, minimum is 4 and the maximum is 4. What about minimum cardinality? Okay, so if I put the minimum cardinality on the one side, or I put the minimum cardinality on the in side, on the many side, one to many. So this is written like 1 to 1, 1 to n, and then it's either m to n or n to n. It's kind of that, or it could be written like this. Okay, so these are describing the minimum cardinality rules. These are describing the maximum cardinality rules. There's no text notation for a degree because that's kind of simple. Okay, is everybody okay so far? All right, just to review, the strong entities are basically going to have 1 row per, right? A student. You're going to have, if you have 100 students, you're going to have 100 rows in your tables, right? If you have employees and you got 50 employees, you're going to have 50 rows in your table. So strong entities are easy to spot. First of all, they typically don't have foreign keys, and they typically have, well, again, 1 row per, right? So that, just noodle it out in your head. For example, in the course, you go to the university catalog and look at the courses, there's going to be 1 row for every course. Okay, cool. So, if I have 3 professors, there's going to be 3 rows. Good. Another simple test, does it contain only those things that do not change over time? In other words, not only does a student have one and only one first name, one and only one last name, it is very rare that the student would come in and make changes. They don't make changes every single time that they apply for a course. They may change their name or change their major, but that's like once, and is not associated with the schedule at all, right? Okay, good. An intersection table. The intersection tables start with something on the left, something on the right, and meets in the middle. If you go back and look at that Chapter 3 intersection Excel file, it's got a lot of good stuff. And is a simple rule for figuring out how many columns are going to be in the compound PK. If I have 2 columns over here in a PK, and 2 columns over here in a PK, when I build an intersection table, it's going to have 4 columns. It's simple math. Just add the number of columns together. Okay, that is about it. I hope you guys got this. This is not really all that complicated. They just use weird terms like non-identifying, weak entity. Don't get wrapped down around to that. Really understanding the patterns we just went through, identifying what is a one-to-one, what is a one-to-many, what are these optional guys. Okay, you guys all right? Okay, we made it through yet another chapter, and I'll see you guys again in the next chapter.